Hi all, this is lecture 11, this is section 3.2, graphs of functions. So far we have talked about the coordinate plane and how we graph points, how we find the distance between 2 points, and how we find the midpoint of 2 points. So now what we want to do is start thinking about graphing things that are more involved than that. So we want to start talking about functions. Right? All right, so here we go. We're going to recall that every point consists of an x and y coordinate. We know that the x comes first and the y comes second. Generally, we view the x coordinate as the dependent variable. Okay, sorry, back that up. Ooh, scratch that whole thought. We generally view the x coordinate as the independent variable. It's independent. That means it can do whatever it wants. It's the one that we base everything on. It's the independent one. The y coordinate is the dependent one. So y doesn't get to be just anything. Y has to be something based on what x chooses or what your choice for x is. And so that means that what we do is you typically pick the x coordinate first, and then we determine what the y is. Okay. Now, if your function is written in the opposite way, meaning it is an x equals, right? So this setup is based on something that is y equals, like this one in example 1. If, for example, somehow you have them switched and it's x equals, then you're going to switch the roles in x and y. X becomes your dependent and y becomes your independent. But typically, we're going to stick with x is independent, y is dependent. What that means is we get the equations of graphs that usually have this form. So y equals f of x, where f of x just means a function with an expression with x, right? And x holds the place, right? So that means do something with the x. So if I replace that x with a number, it means replace the x in the function with a number and figure out the answer, okay? So anytime we want to graph a function that's y equals negative 2x plus 3, for example, here's what we're going to do. We're going to draw a set of axes. So let's start with that. So I'm going to draw my set of axes. And then we're going to create a table with x's and y's in it. So I'm going to create a little table of values here, and I'm going to have x values and y values. And we're going to choose several values for x. And you want to choose different types of values, right? So you want to choose always 0. You want to choose positives and negatives. I like to choose a good, 6, unless I can figure out sooner than that what's going on. So I like to choose 0, 1, 2, 3. Let's go with 7. And then -1, -2, and -3. And see what happens. Okay, so x is independent, meaning I get to choose. Y is dependent, which means that the y value is dependent on the function. So I'm going to go back to this highlighted y equals negative 2x plus 3, and I'm going to plug everything in. So if I plug 0 in there, 0 times -2, remember I'm plugging in for x. 0 times -2 is 0, plus 3 is 3. Then I have plug in 1. 1 times -2 is -2, plus 3 is 1. 2 times -2 is -4, plus 3 is -1. 3 times -2 is -6, plus 3 is -3. Then we do the same with the -1, so be careful with your signs here. -1 times -2 is +2, plus 3 is 5. -2 times -2 is +4, plus 3 is 7. And -3 times -2 is 6, plus 3 is 9. Okay, and now we're going to go ahead and graph the points. We're going to plot the points and see if we can determine and see how we can connect them. So I'm going to plot 0, 3. So 0, 1, 2, 3. That's what we would call our y-intercept, because that's where my graph is going to cross the y-axis. 1, 1 would be this point. 2, -1. 3, -3. So I'm going out to 3 and down to -3. -1, 5. So -1 and up to 5. -2 and up to 7. -3 and up to 9. And you can see what's going on here. I've got a line that I can connect. Okay, and so that is the line y equals -2x plus 3. Okay, and that's how I can graph my function. All right, so let's graph some other ones. So here's another one, y equals x squared. So we get our axes. And I'm going to create an x and a y chart. And I'm going to go with the same numbers, 0, 1, 2, 3, -1, -2, -3. Now, if I don't see a pattern within these first few, then I might add different numbers, right? So I might say, oh, I don't see what's going on over here. Something weird's happening in the negative direction. Let me try some more negatives, right? You can do that to compensate. So if we plug in 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Negative, and by the way, I'm plugging in here, which is why I'm squaring each thing. -1 squared is 1, -2 squared is 4, -3 squared is 9. And let's go ahead and plot these points. So 0, 0 is at the origin. 1, 1, let me get some spots here. Okay, 1, 1 would be here. 2, 4, over to the right 2, up 4 would be about here. And 3, 9, so that would be up here. In the other direction, -1, 1 is here. -2, 4 is here. And -3, 9 is up here. And now you can kind of notice that this seems to have some symmetry. It seems to be balanced on each side. And we end up with a shape that looks like this. Right? This is y equals x squared. This is a parabola. Okay, it kind of has that almost a U shape, but it's a little pointed at the bottom. Anytime you get something that has a highest is quadratic, right, that you would solve with the quadratic formula, you're going to get a parabola. Okay, notice that the number in front of the x squared is positive, and notice that our parabola opens up, right? It opens this way as opposed to opening down. Okay, usually if the number in front of the x squared is negative, it's going to open down, and we'll talk a lot about that later. Okay, but we can graph any function using this strategy. Let's take a look at x cubed. So set of axes, and I'm going to go ahead and put some on here. And actually, I think I want to extend this 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's probably not high enough, but we'll go with it. Let me try moving it down. Okay, then let's choose our x and y's. And I'm going to go with the same 7 numbers. All right, well, now we're cubing them because we're plugging them into this part. So to get my y value, I plug in the x. So 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, right? You're multiplying times itself 3 times. 3 cubed is 27. -1 cubed is -1. -2 squared is -2, right? -2 times -2 times -2. -3 cubed is wait, hold on, I did this wrong. Oop, not -2, -8, and -27. So if we then go ahead and plot these points, I have 0, 0 at the origin. I have 1, 1. I have 2, 8. About here. And then I have 3, 27, and that's going to be way up here off my chart. Then I have -1, -1, so down here. -2, -8, somewhere down in here. And -27 for 3 is way down here. And if I connect those, I get something that looks like that. Okay. And that's pretty typical for a cubic. It looks like kind of 2 parabolas that are connected almost. So we get this part down here at the bottom, and then we get this part up here at the top. Okay, it has some curvature. Typically you have one that goes down and one that goes up. They can flip-flop depending on what the signs are, but that's pretty typical for a polynomial, particularly one with odd degree. Okay, and next we want to talk about graphing a circle. So if we take a look at a circle now, notice that I have x and y here, right? So an x and a y, but it's not y equals, okay? And that's because a circle is not technically a function, okay? We'll talk about that later. But I can write the equation of a circle that has the center h comma k when it looks like this. So here's my H and here's my K, and that will become my center. And then we have the R over here. This represents my radius. So I can draw a circle by pinpointing where the center goes and where the radius is. Okay, so we're actually I'm gonna do example 5 before I do example 4. I think I put them in the wrong order. So let's jump down here. Now, if I want to do the same thing, if we think about solving this for y, okay, let's subtract the x from both sides. So that's going to give us y squared equals 9 minus x squared. And then to get y by itself, we take the square root, but we're going to get a positive and a negative for each value, right? So this is why it's not a function, because to be a function, when I plug in x, I have to get exactly one y value. I can't get 2. It won't pass what's called the vertical line test, but we'll talk about that later, okay? Because we get a positive and negative, we get multiple values. So let's start the same kind of thing. Let's have our axes. And let's get our chart going. So we're going to plug in 0, 1, 2, 3, -1, -2, -3. Okay, so these numbers might be a little bit weird, okay, but we're going to try it. So when you plug in 0, nine minus 0 is 9. Square root of 9 is 3, and you get plus or minus 3. So I get 2 values, right? What that means is I'm going to get 0, 3, and I'm going to get 0, -3. So if I'm graphing that, actually, we'll go with it. Okay, so positive and -3 at 0. So positive 3 and -3. Keep in mind that I'm sketching here, so this isn't going to come out perfectly. When you plug in 1, right? So 9 minus 1, 1 squared is 1, 9 minus 1 is 8. So this is 1 and a root 8, and 1 and -8. Okay, now if we take the square root of 8, use your calculator, you get 2.8. So that means that I'm going to graph positive 1 and 2.8. and -1 and 2.8. Wait. I lied. 1 and -2.8. There we go. If we plug in 2, okay. If we plug in 2, that's 2 squared is 4. 9 minus 4 is 5. So this is 2 and the square root of 5, along with 2 and the square root of negative square root of 5. And the square root of 5 is 2.2. So that means when I graph this, it's going to be like here and here. And when I plug in 3, 3 squared is 9. 9 minus 9 is 0. Square root of 0 is 0. So I get 0 here. I will also get 0 when I plug in -3, but we'll get there in a second. All right. And then let's see, we can plug in -1, and what happens here is when you square -1, you get 1. So you're going to get exactly the same values that you did over here. So it's going to match. So this will be -1 and root 8, along with -1 and -8, -2 and root 5, and -2 and root 5. And when you plug in -3, you get 0. So if we plot those points as well, we're going to get exactly the same thing, but on the other side. So over here. And so what happens, and it looks wonky because I'm sketching, is that you get a circle, okay? So now what you noticed before is that I gave you this format for what a circle looks like. It's x minus some number squared and y minus some number squared, and then a radius squared. So if I look at that one here, and I create the format, okay, x squared is x minus 0 squared because it simplifies down to just x squared. Y squared must come from y minus 0 squared as well. And 9 squared, 9 is 3 squared. Okay, so that means that this is my h, this is my k, and this is my r. So that means I have a center is at 0, 0, and its radius is 3. And so you can kind of see that here. The center of my circle is here, and its radius is 3. Okay, so if I draw it using that information, I would do this. I would say, okay, my center goes here at 0, 0, and I wanted to have a radius of 3, and then I have a circle that has that radius. Okay, and I can draw, and the radius is 3. Okay, so that's how we draw our circles. Okay, now if I go back up to this one, to example 4, I can now use that information, and I don't have to plot points. I can plot points, but I don't want to because it'll be easier if I do it this way. Now, remember that the format is x minus something squared plus y minus something squared plus something squared. Sorry, equals something squared. Okay, now I have plus 2 here, and I need it to be minus, so I can pull a minus away and make this a negative 2 right there. Okay, so x minus negative 2 is the same as x plus 2. The 4 is already minus, so I can leave it. And then 36 is what number squared? Well, 36 is 6 squared, so I'm putting that 6 on the inside. That tells me that, again, this is my h, this is my k, and this is my r. So this is a circle with the center at negative 2 comma 4 with the radius being 6. So if I want to sketch that graph, I find negative 2, 4, and a radius of 6. So 1, 2, 3, 4, 5, 6. So here's a point on my graph. Here's a point on my graph. 1, 2, 3, 4, 5, 6 over here. 2, 3, 4, 5, 6 over here. And there's my circle. Okay, we're sketching, so I'm kind of sketching it in to make it look more circular, right? But then your radius of 6, whoop, your radius of 6 is right here. Okay. All right.